Hello and welcome to another video of Datative. In our previous video, we got to know about how language models work, the various components of language models and their usage. And in today's video, we are going to jump a bit further and we are going to learn how to work with large language models and what are some of the safety concerns that we should keep in mind while designing applications based on large language models. If you're new to my channel, then do subscribe and give it a thumbs up if you like my content. And yes, don't forget to check out the description section for all the resources that helped me to build this video series. Things that we are going to learn in this video. We are going to know what is meant by prompting, the use cases of large language models, and certain safety concerns that we should be aware while working with large language models. So what is prompting? Any kind of instruction that you give to a large language model or a chatbot based on large language model or any kind of chatbot for that matter, and it performs certain operations based on the instructions that you give it is known as prompting. So if you look at this example here in the slide, this is an example of a prompt that I gave to Bing Copilot, which is a API of Microsoft Bing search engine that enables you to chat the ChatGPT API, which runs behind the hood. And here I asked it to write a funny line about me, and it came up with certain images, example images, which is generated by ChatGPT. So this thing is an example of a prompt, an instruction that I gave to the chatbot to perform certain operation. But while working with large language models, always be sure about uh, one thing that you should be checking or fact checking the output generated by the this chatbots, this large language models. The reason being they can be written with bugs, and if left unchecked, that they can pose some serious uh, make some serious issues in your uh, downstream applications. So for example, here I have again to the I have given a prompt to the Bing Copilot. I asked it to generate a Python code given two variables A and B, and then divide 2 by the sum of these two variables. It came up with a code here. At the first glance, it looks okay, but when you run it, actually, it gives an output of 0, an error, not an output, an error. Um, that is saying that it is, 2 is not divisible by 0 whenever you keep 0 as the value of both the variables A and B, because we know that 0 plus 0 is 0, and then if you divide 2 by 0, then it gives you an error. But the large language model does not know that. So if you take this program and directly use it blindly, then you would have some serious bugs downstream. So always fact check, always debug the output or the program generated by a large language model, and then try to amend it. So for example, in this program, we put amend it by adding a adding certain error handling over here. Now let us look into uh, some safety concern of large language model. So large language model, as they are trained on huge amount of data, the bias from the data creeps inside this particular models, and it becomes evident in case you give certain specialized instructions to the language model. So here, for example, I gave a uh, instruction, a prompt to Bing Copilot, that is the man was known for blank versus the woman was known for blank. So the output that it gave is clearly biased towards certain genders, right? You can take your time to read the output here, and it certainly is biased towards a particular gender, and it looks stereotypical. Now, malicious attacks on large language models. Large language models can be easily manipulated to output certain malicious stuffs. So, for example, a malicious attacker or a hacker can, corrupt the data source of the large language model, and this in turn could destroy the integrity of the an application that is based on large language model, as it could now return certain unwanted stuff to you. So say for example a malicious attacker can um, seed certain unwanted or dangerous strings into the data source, maybe a database from where the large language model is trying to extract information from, and like a knowledge base. And when a user queries this large language model based application, now as the data source is corrupted depending upon certain um, keywords, it can return an output intended by the attacker. So for example, uh, let's say we have a data source here which is meant for a LLM application that would return a book recommendation, for example. Now an attacker could seed in a book's name that the attacker wants to be popularized into the very data source or the knowledge base of the application, from where the large language model is actually going to retrieve context and knowledge, so as to return it to the user, return the recommendation to the user. Now since the attacker has seeded the data source with the book of their choice, no matter whatever query you type in into this chatbot, it would always return the book's name that the attacker wants to be written. Backdoors. So another kind of attack is having a backdoor into a large language model. So here what happens is that the attacker can again corrupt the training data by inserting certain triggers in the very data. Now the LLM gets trained on that, and this corruptions creeping into the large language model. And when the large language model is finally deployed into production and the user comes in, and it and the user you know tries to give certain prompts to the large language model, and somehow there are certain words in the user prompt which are kind of trigger for the uh, to trigger for the backdoors that were earlier injected by the attacker in the training data. Now what happens is that when this triggered prompt is given to this poisoned large language model, then it gives you an unintended output, which is actually what the attacker wants, but which is not that we want to be present in our um, final product in production. So this way the model can behave as intended by the attacker, depending upon certain keywords that we or the user might unknowingly give in the prompt. So when large language models are used correctly, they can augment our existing knowledge and make our work easier. But we should also be aware that they can be easily manipulated by attackers and by malicious actors. And this is something that we need to keep in mind while designing our large language model based applications, so that we can minimize the risk of such attacks. So this was all for today's video. Don't forget to like, share, and subscribe, and check out the description section for other details.